For more than 40 years, architecture, form, space, and order has served as a classic introduction to the basic vocabulary of architectural design. Francis D.K. Ching's award-winning college textbook is one of the best-selling architecture textbooks published by Wiley, often the number 1 or number 2 architecture title each year. His book is currently in use in nearly 100 colleges and universities in the USA, where it is a top 3 title by student enrollment in both architecture and design courses. Ching begins the section on proportioning systems for aesthetics on page 312 of the text by pointing out the imprecise and subjective nature of proportioning systems for physical dimensions. Ching states the purpose of proportioning systems or theories as: the intent of all theories of proportions is to create a sense of order and harmony among the elements in a visual construction. Next, Ching begins to define ratio and proportion using a definition by Euclid. A ratio refers to the quantitative comparison of two similar things, while proportion refers to the equality of ratios. Underlying any proportioning system, therefore, is a characteristic ratio. To help further clarify the illustrations found on page 312 of Ching's book, we will discuss the concept of ratio in more detail using visual analogies and simple geometry. Geometry serves as a creative tool for engineers, artists, and architects. Paul A. Coulter's textbook, Squaring the Circle, Geometry in Art and Architecture, is the first textbook to cover both art and geometry extensively. Each chapter introduces mathematical concepts geometrically and illustrates their non-traditional applications in art and architecture throughout the centuries. We will be using Coulter's textbook as a reference for the mathematical terms in this project. Coulter defines a ratio as the quotient of two quantities, that is, one quantity divided by the other. Therefore, the ratio of P to Q is PQ. Explaining ratio using fractions is the typical method used today for teaching the concept. The problem with this type of explanation is that it tends to be abstract with no direct relationship to design concepts. This project intends to take a different approach to explaining the concepts included in Ching's textbook by using hands-on exercises intended to provide a more visual and direct relationship to the concept of proportion in design. The focus of this concept is to demonstrate how pre-industrial artisans may have developed their designs using systems of proportion. The goal is to present the concepts in their simplest terms and not necessarily how they were once used. Whenever possible, the project strives to eliminate any type of numerical dimensions, equations, or elaborate examples. The user must adopt a mindset of using physical dimensions placed on the paper without any reference to standard measuring systems. Simple applied geometry will be utilized to express the concepts. In an attempt to present the concepts as relevant to the modern design process, practical dimensions will be discussed when appropriate. For the most part, all that is needed is a compass, straight edge, pencil, and paper. First, we have a circle of any radius. A line can be drawn directly through the center at any angle. Then the center is filled on one side of the line. It may be obvious that these two different sections are each equal to half the circular area. However, we will systematically determine how a ratio is expressed. Ratio is about comparing one quantity or amount to another. In the circle, There are two sections, a marked section and an unmarked section. Since the circle is divided through the center, we can determine that the two sections are equal in area. In other words, if the sections were separate containers, they would hold an equal amount. Now assume the amount of area in each separate section can be measured as 1 unit. We can now compare the area of these two sections and describe them as having a 1-to-1 ratio to each other, mathematically noted as 1-to-1 or 1/1. A ratio can be expressed several ways depending on what is being compared. The marked area of the circle can be compared to the entire area of the circle. One unit of the circle compared to 2 units of the circle. This is a 1-to-2 ratio and can be written as 1-to-2 or as a fraction, 1/2. As Coulter's definition tells us, a ratio is the quotient of two quantities, that is, one quantity divided by the other. Dividing 1 by 2 gives a decimal of 0.5. This can also be thought of as half the area of the circle. In other words, the math proves what we instantly saw at the beginning. The area of the marked section is half of the total area of the circle. How does this apply to proportion? Consider you are cooking a single serving of rice for yourself. The recipe states to boil 1 cup of rice in 2 cups of water. Comparing the amount of rice to the amount of water yields a 1-to-2 ratio. Now consider that you must cook rice for yourself and a friend. For 2 servings of rice, you need 2 cups of rice and 4 cups of water. The 2-to-4 ratio can be reduced to its simplest term of 1-to-2. Here is where we arrive at the concept of proportion. Notice that even when the quantity changed from 1 serving to 2 servings, the ratio reduced down to the same value. The amount of ingredients for cooking rice for 1 serving is proportional to the amount of rice for 2 servings. Referring back to Coulter's definition, when 2 ratios are set equal to each other, the result is a proportion. If the ratio of A to B equals the ratio of C to D, we have a proportion. Different quantity, yet same ratio. Proportional. As a design concept, proportion is about the relationship between the ingredients, or parts. A classic definition of proportion in design can be described as the parts are to the whole as the whole is to the parts. Ching's textbook begins the section for proportioning systems on page 312. On this page, fractions and equations are used to explain the concepts of ratio and proportion. We will break down these equations and apply them to the graphic below. Proportion is the equality between 2 ratios in which the first of the 4 terms divided by the second equals the third divided by the fourth. How can we apply this to design? Apply the rice cooking analogy to each fraction. The fractions represent a ratio. Different quantity, same ratio. Again, proportional. The next set of fractions or ratios refer to the illustration below. Think of the next set of fractions or ratios in terms of spatial relationships. Each part relates to the others in the arrangement of the whole. The length of side A relates to the length of side B by a ratio. The specific ratio is not important here. Length A is to length B in the same ratio as length B is to length C. A is to B as B is to C, as C is to D, as D is to E. This creates a spatial relationship. Different lengths related to each other by the same ratio, otherwise known as harmonious proportions.